Hello, my name is Gavin Rory, and this is my term report 7 on Kamiak Butte. In this video, I will be going over various topics on Kamiak Butte. These topics will include geologic foundations of Kamiak Butte, Columbia River basalt flood, loess soil, climate interactions that contributed to Kamiak Butte, including air masses, macroclimate, continentality, and topography. Kamiak Butte's biome, north side of Kamiak Butte, and the south side of Kamiak Butte. Geologic foundations of Kamiak Butte. Roughly 50 million years ago, Kamiak Butte, which rises high over all other nearby Palouse hills, was once a sandy seafloor. The Pacific Northwest, Washington, and specifically eastern Washington, were all underwater 50 million years ago, but this is where the story of the Palouse starts. The Juan de Fuca oceanic plate slid underneath the North American continental plate, creating a subduction zone offshore. Since the Juan de Fuca plate slid underneath the North American continental plate, this gave rise to Washington ground levels and lowered the sea levels. This is what allowed Washington, specifically eastern Washington, to finally rise above sea level and create new land in the Pacific Northwest. Columbia River basalt flood. 17 million years ago is when the magma erupted from the Cascade mountain range and turned into basalt lava. The basalt lava began to flow throughout the entire Pacific Northwest and even reached a few surrounding states outside of the Pacific Northwest, such as California and Nevada. The areas touched by the basalts were carved out by the flooding or were smoothed in the basalt lava. The only areas touched by basalt lava and were not affected were areas that were tall in elevation and wouldn't allow the lava to flow over it. These areas are defined as buttes, a tall hill with a flat top and steep sides. The buttes were made from quartzite sand that had been compressed and heated to make the hill. What gave the hill elevation was the accretionary wedge, which caused the quartzite to rise in elevation. An example of a butte that made it through the blood basalt untouched was Kamiak Butte. Loess soil. Many years ago, there was a major glacier that was flooding all over Washington. One of the most important organic matters transported by the glacial flood waters was loess soil. Loess soil is fertile soil that is very ideal for agriculture and for any plants to grow. Since the flood waters washed away the loess soil from the scablands, it left the area of the Palouse very dry and nutrient deficient, making it hard for anything to grow. Glacial floodwaters were not the only means of transportation for loess soil. After the water from the glacial floods washed away, the wind began to transport loess soil all over the Pacific Northwest and distribute it based on particle size. Fortunately enough, by luck, a large amount of loess soil was dropped over the Palouse, making it once again rich farming land. Areas affected by the flood basalts, glacial floods, and even the buttes all received loess soil from the sky. There were upwards of 40 feet of loess soil distributed across the Palouse. This is what made the Palouse's land once again fertile for farming. Climate interactions of Kamiak Butte. Air masses. Air masses can be described as a massive amount of air with the same pressure, temperature, and humidity throughout the air mass. An air mass has the potential to reach an area of hundreds of miles. The massive amounts of square miles an air mass can cover will affect the climate and weather of the area covered by the air mass. There are different types of air masses that all have other effects on weather and climate. The air masses traveling through Kamiak Butte are marine modified continental, typically dry due to passing through the Cascades and losing their moisture interacting with the mountain range. Macroclimate. Macroclimate is defined as a broad-scale climate of large region within a continent. An example of macroclimate would be the climate of the Pacific Northwest over the past 200 years. In North America, there are many macroclimates including Arctic, subarctic, marine modified continental, Mediterranean, warm desert, continental, humid continents, and humid subtropical. These various macroclimates are influenced by topography, continentality, latitude, and the origin of an air mass. Kamiak Butte is a marine-modified continental macroclimate. It receives dry air masses that pass through the Cascade Mountain Range from the west side of Washington. Continentality. Continentality is defined as the influence of landmass on climate. This means the further inland from the ocean, the less moderating effects of the ocean on climate there are. The ocean works like a big heat sink that absorbs heat from all over the world. The ocean's heat sink moderates the coastal region's climates. The sea absorbs the solar radiation from the sun during warm parts of the year or day. Once the heat is trapped, it is circulated down into deeper parts of the ocean, which consists of cooler water. During the colder months of the year, the heat is then released back into the atmosphere. Kamiak Butte is far away from the ocean for being in the west side of Washington, and this is why the Palouse is much drier compared to the west side of Washington. Eastern Washington experiences more extremes of temperature because the ocean heat sink does not moderate the climate. Topography. Topography is the study of land surfaces, forms, and features, including how those forms and features influence the climate of their surrounding regions. Many mountain ranges are the biggest topographical influencer for the climate of surrounding regions. The mountains act as a natural barrier to any passing by air masses and prevent them from going on their way undisturbed. As air masses rise up in elevation next to mountains, they lose moisture due to their very cool air. As moisture is lost from the cooling of the air masses, clouds are formed, which create snow and rain. The topography is a major reason why eastern Washington is much drier than the west side of Washington. If the Cascade Mountain Range wasn't blocking the air masses traveling to the Palouse, it would receive significantly more precipitation than it ever has. Kamiak Butte's climate. The table on the left shows us what an average year looks like for the climate of Kamiak Butte. The table shows us the average amount of precipitation for each month and the average temperature for each month. This gives us an accurate representation of what a year-long weather and climate looks like for Kamiak Butte. Kamiak Butte's biome. Kamiak Butte is a western interior shrubland and woodland biome. Western interior shrubland and woodland biomes occur on the west side of the North American continent. This biome runs throughout Washington, Utah, Idaho, Alaska, Colorado, and Nevada. This biome can be seen also stretching across the West North America and into Canada. Examples of this biome also occur in Africa, South America, the Middle East, Asia, and Australia. Kamiak Butte is a great example of a western interior shrubland and woodland biome. North side of Kamiak Butte. On the north side of the butte, there are ample amounts of Douglas fir, creating shade necessary for plants to grow on the forest floor. There are native plant communities, understory vegetation, and high levels of biodiversity. This is all due to the ponderosa pines and Douglas firs creating enough shade for the plants growing beneath the tree canopy. South side of Kamiak Butte. Along the southern side of Kamiak Butte, there is blue bunch wheatgrass, ponderosa pines, and Douglas fir. There are very sparse amounts of these trees because photosynthetic radiation occurs early in the spring, which stresses the plants growing on the south side because there is not enough precipitation. There is also a lack of shade due to the sparse levels of trees on this side of the butte. This results in insufficient amounts of plant biodiversity, meaning mainly just grasses grow on the floor. Thank you for listening to my presentation on Kamiak Butte. Have a great day.